Again, continuing with our quadratic formula, we are going to solve example 3. And once again, we are not in standard form, so I'm going to start there. So subtracting 8x from both sides so that we can be equal to 0. And noticing that none of those are perfect squares, so we're going to go x squared minus 8x plus 16. Now, probably some of you are looking at that going, wow, that's easy to factor. I'm just going to solve it using factor. Normally, I'd say that's fine. Go for it. It's easy to factor. That's definitely the easiest way to do it. But we want to practice the quadratic formula, and this one's going to be one of our cases that we haven't looked at yet. So we're going to do it using the quadratic formula for the sake of our notes. But in the future, if you were just asked to solve by factoring would definitely be the easiest way to go here. So we're going to start by picking our a, b, and c. A is 1. B is -8. And c is 16. Just realized I've done a lot of examples where my b was negative. And we want to make sure that we understand when it's negative that the -8 becomes a +8 in that quadratic formula. Just don't overuse it. Just happens that my first 3 examples here all have a -b. I'm going to start with my discriminant, so b squared minus 4ac. So replacing b with -8, you absolutely need the parentheses there. Replacing a with 1, replacing c with 16. So -8 squared is a +64. -8 times -8 is +64. And then here I've got -4 times 1 times 16. That'll stay a minus. And then 4 times 16 is 64. 64 minus 64 is 0. So our discriminant is 0, which we know means that our solutions, we have one real solution. Let's go ahead and find that solution using our quadratic formula. So the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So we have -8 plus or minus the square root. Again, I'm going to plug in the 0. I'm going to put in that b squared minus 4ac. I'm not going to recompute it. All over 2a. -8 is a +8. The square root of 0 is 0. Notice when I do 8 plus 0 or 8 minus 0, I get 8. So if you look back at example 1, when I got to this step, I separated into 2. I did 8 plus 0. I did 8 minus 0. But in either case in this instant, I get 4. So this is that case where we actually are getting 2 solutions, just the same solution twice. So graphically, what's happening, it's the one where our vertex is on the axis. So you see I graphed the corresponding function, x squared minus 8x plus 16. It's the one where our vertex is right there on the x-axis. That's what's happening there. So in this case, I get essentially one solution. Really, it's the same solution twice. It's called a double root. We do have one more example to do. We will do that one together. But that is our 3 cases of what can happen. We are going to look at example 4 because there is one that's the one that we haven't done, which is the one where our discriminant is negative.